Good morning, students. In previous period, we have discussed flow of heat along the wall of a cylindrical tube. Now, in this period, we will discuss about the comparison of the conductivities of the different metals. For comparing the conductivities of the different metals, we will discuss about the engine house experiments. The experiment is used to compare the thermal conductivities of the different materials or metals. Take a box containing hot water or oil. Materials are taken in the form of long, thin rod, identical in size and shape and polished similarly, as shown in the figure. The emissive power E for all the rod is the same. Rods are fixed at the base of the vessel and their portions outside the vessel are coated uniformly with wax. Oil or water is maintained at boiling point. Heat is conducted along the rod and is steady state. Wax is found to be melted to different lengths depending upon the value of K for different materials. Let the length up to which the wax has melted be L1, L2 and L3 and so on, etc. Theta 0 be the excess temperature of the heated ends. Then the equation representing the temperature distribution along each bar is in experiment is theta equals to theta 0 into e raised to minus mu x. Let theta m be the excess temperature of the melting point of wax above the room temperature. As first rod, Qm equals to theta 0 e raised to minus mu 1 into L1. For second rod, Qm equals to theta 0 e raised to minus mu 2 into L2, and for third rod Qm equals to theta 0 e raised to minus mu 3 into L3 and so on. Therefore, Qm equals to theta 0 e raised to minus mu 1 L1 equals to theta 0 e raised to minus mu 2 L2 equals to theta 0 e raised to minus mu 3 L3 equals to and so on. Therefore, mu1 L1, mu2 L2 and mu3 L3 equals to and so on. But mu1 equals to under root of EP upon K1 into A. Mu2 equals to under root of EP upon K2 into A. Similarly, mu3 equals to under root of EP upon K2 into A. Here E, P and A for all the rods are same, as they are identical in size and shape. Therefore, L1 into under root of EP upon K1 into A, L2 equals to under root of EP upon K2 into A equals to L3 into under root of EP upon K3 into A equals to and so on. Therefore, this can be written as L1 upon as EP upon A is same for all the rods. Therefore, this can get cancelled. Therefore, L1 upon under root of K1 equals to L2 upon under root of K2 equals to L3 upon under root of K3 equals to sin so on sin equals to constant. That is K1 upon L1 square equals to K2 upon L2 square, that is equals to K3 upon L3 square equals to constant. The L square, L2 square and L3 square, these square b is these values are taken outside this square root and hence it becomes L1 square, L2 square and L3 square. That is the conductivities of the material of the rod is directly proportional to the square of the length up to which the wax melted on the rod. The equation 24 is used to compare the thermal conductivities of different metals. In this way, we have seen how to compare the conductivities of the material with the help of this method.